Hi everyone, we're going to find exact values of inverse trig expressions. We're using sum and difference identities here. Basically we have a sign of alpha and beta. So what we want to do is use sine of alpha minus beta equals sine of alpha cosine of beta minus cosine of alpha sine of beta. And what we need is we need our sine of alpha, cosine of alpha, cosine of beta, and sine of beta. Now, I know my students, I have them know their identities, or their Pythagorean triples. And we know 3, 4, 5 are identities, or our triples. 3 squared plus 4 squared equals 5 squared. If you know those, it makes life easier with this. So I know that sine of alpha is 3 over 5. And I know cosine of beta is negative 4 over 5. Since this is the inverse, I know this is in quadrant 2. So I know beta is in quadrant 2. Therefore, I know that sine is also in quadrant 2, and sine is positive. So this would be 3 over 5. So it's basically your x is negative 4, your y is 3, and your r is 5 for that one. For the sine one, the alpha, we just know this is 4 over 5. Because again, we have our 3, 4, 5. In this case, your x is 4, and you have 3, and r is 5. So, all you have to do is fill everything in. I hope I did this right. So we got x and y. Okay, so we just fill everything in, and you get sine of alpha is 3/5, and cosine of beta is negative 4/5, minus cosine of alpha is 4/5, and sine of beta is 3/5. So we're going to have negative 12 over 25 minus 12 over 25. And this is going to equal negative 24 over 25. So our answer is negative 24 over 25. As you can see, these can get more complicated as the values get different. But if you know your triples, it makes everything easier. Okay, thank you and have a nice day. Bye-bye.